variables are correlated, and if you actually expand the covariance matrix of the OLS estimators, what you'll find is that once you have more than one independent variables in the model, then you also have in the denominator the correlation coefficient terms between, pairwise correlation coefficient amongst the variables. So definitely variables are correlated, and a high correlation between the variables necessarily should not cause a problem as far as multicollinearity is concerned, because multicollinearity more or less is a problem of degree. If and only if the variables are perfectly correlated, by that, will not be able to satisfy the assumption number 2, that is your identification condition. In that case, the number of explanative variables that you have used, it does not satisfy the full column rank. So as long as they are not perfectly correlated, and if the researcher, in this case you or any other who would have solved this problem, if he or she is fine with sufficiently high correlation amongst the variables, it is fine, as long as it does not pose that much of a problem. So, and I'm sure that once you would have checked for multicollinearity, the values or the BIF, if you have calculated, it does not come out that significant. So more or less in this case, in this particular case, multicollinearity was not a problem. And do always remember this point, that whatever explanative variables that you have undertaken, they will definitely be correlated. And if there is no correlation amongst the variables, then you're fine with just having all the partial correlation coefficients or partial regression coefficients that we get. They are simply the simple regression coefficient of dependent variable on each of the independent variables separately, which is also called Frisch-Waugh theorem. That is, if the variables are perfectly orthogonal to each other, in that case, they are not at all related. In that case, what you're facing is, let's say if you have 5 number of explanative variables, then you can simply run a 5, simple regression equation, and the coefficients that you get in multiple linear regression and simple linear regression, they'll be same. So variables are correlated almost all the time. If it poses a problem, if it poses a problem as far as having a higher variance inflation factor, in that case, the confidence intervals which are based on these standard errors, they no longer are tenable. So that's the only problem that as far as multicollinearity is concerned. Is that clear?
Yes, sir.
So correlation. Yeah.
I have another question.
Yeah.
So as far as writing the course and understanding the data set, I had an issue understanding the data set in the first place, because it was percentage of people who had above certain income, and percentage of people with higher education. That was the kind of data that we had. So when it came to interpreting the coefficients, I had a little confusion, like how exactly do I write? What exactly does these coefficient mean? Because it was percentage people who consider their occupation prestigious, if it is better or good. So I had tough time interpreting the coefficient. So if you could help with that thing, that would be great. Coding wise, it was.
I'll do that once. I'll keep on correcting the assignment. So I'll write my comments in that. So don't worry for that.
Okay, sir.
Rahul, if I may help with that.
Sure, Neil. Bata.
Sir, is that fine?
Yeah. Go on.
So Rahul, how I was seeing it is, as you also would have seen, they are both percentages above a certain benchmark, right? 3,500 income and high school. So how I was seeing it, assume that we see that a rise in income gives a rise in education variable. So how I was seeing it is that professions that require more people, professions that have more people with higher incomes tend to have people who are more educated. Okay, I will not say more educated in terms of absolute terms, but rather in terms of benchmark. So again, professions that tend to have more people above the benchmark tend to have more people who have studied above the benchmark. So that is how I see it.
I have interpreted in the same way, but like in general, we just tried like with 1 unit increase in so and so, the other thing is moving by so and so. But
For
actually,
every for every 1 percentage point people crossing the
any goal,
income
yeah.
benchmark, it will give hopefully a rise in, let's say, assume it was 1.5, I'm just putting a number randomly, it will give a rise to 1.5% increase in the number of people who have uh, completed their high school degree, percentage points.
Yeah, I think more or less I've interpreted in the similar way. But when I was discussing with a few other people, so there was very vague interpretation to those coefficients. So that's why I was wondering if I'm thinking in the right direction. I think like I've done it that way only. Otherwise, Pranav sir, once you would be checking those assignments, I would really appreciate if you could just mention those comments regarding
Yeah,
the.
yeah, I'll definitely mention all the comments as far as the questions are concerned.
All right, sir. Thank you so much.
Is there
So,
anyone? Yeah, go on.
so you just said that if there is no correlation between the variables, we can run a simple regression. So,
Yeah,
isn't a multiple regression also possible in that case?
come again.
So, when there is no correlation between the variables, can
Yeah.
we also perform a multiple regression and not a simple regression?
Yeah, you see, the point that I mentioned was that if the variables are orthogonal to each other, you see, when you have a multiple linear regression model, then all these coefficients, they are partial regression coefficients, meaning which, if you're talking about beta 1 hat or beta 2 hat, then it just gives you the influence of x1 or x2 on y, keeping all other variables constant. Why do we say keeping all other variables constant is because there is some sort of correlation, some sort of relationship between or amongst the explanatory variables themselves, which somehow influence the variable together. So when we talk about beta 1 hat or beta 2 hat separately, while we talk about multiple linear regression model, then we keep all other factors constant, or we try to understand the influence of x1 or x2 or x3 on y in presence of all other variables in the model. This is how you interpret it. But if the variables are not correlated, then all the coefficients that you have in front of you, whether it's beta 1, beta 2, beta 3, they all are simple linear regression coefficient. In that case, there is nothing called partial correlation coefficient because the variables themselves are independent of, they are not related to each other. So there is no talk about partial correlation as well. And since there is no talk about partial correlation, either you can have the multiple linear regression model, or for each of those correlation coefficients can automatically, or sorry, regression coefficient can automatically be obtained if you simply run a simple linear regression model of each of these variables with a dependent variable. So this is what is called as Frisch-Waugh theorem. That is, if the variables are not correlated, that is, if the variables are orthogonal to each other, then the partial regression coefficient is equal to simple linear regression coefficient. Is this clear?
Yes, sir, got it.
Yeah.
And sir, I also had a hard time interpreting the regression diagnostic plots.
All right. That is the main purpose. I like my comments, and besides, I'll also discuss this question in class, and not just this question, because you see, अभी तक हमने जितना भी cover किया है, they all are, simply we are assuming that model will filter. So we'll discuss the model diagnostics a lot because that is the basic building block of, of our exercise. At least, we must be able to understand कि कौन सा model अच्छा है, कौन सा model नहीं अच्छा है. तो वो अगर हमें decide करना आ गया, and so we'll discuss all these model diagnostics plot and some of the examples I have just mentioned in the question. And but we'll discuss all this. Don't worry. All these
And
model diagnostics will discuss. Yeah.
and so which type of test to rely on?
Come again, dear.
And so which type of test to rely on to test for a particular problem?
See, that again is a trial and error method, Ayushi. There is no such, hard and fast rule where you can say, this is the test which you can, which uh, uh, should be relied upon. एक जो general common understanding है कि if the model is good, or if the, if while checking the model, if not enough problems are there, the almost all the graphs or all the tests that we do, more or less they will give you the same results, whether it's quantile plot or residuals plot. So more or less this is a common understanding. And रही बात कि कौन सी टेस्ट और या कौन सा टेस्ट reliable है, that again depends on researcher to researcher. So it depends completely on you which test you want to undertake. So ideally क्या करते हैं generally हम लोग सारे plots और सारे test run कर लेते हैं, so that if someone asks us कि आपने ये किया तो हम बोल सकते हैं या हमने ये किया, and then उसके basis पे we have proceeded ahead. This is the general rule, because this again is an entire process of trying and getting back to the model, then again trying and getting back to the model. So कोई एक हार्ड एंड फास्ट रूल नहीं है. तो आइडियल वे है कि आप सारे ऑलमोस्ट जितने आपको टेस्ट पता है एटलीस्ट जो कॉमन से वो आप प्रोसीड कर लीजिए.
And sir, if supposedly we face a problem,
Come again?
and supposedly, sir, we face a problem that there is a problem of heteroscedasticity or multilinearity maybe. So then the transformation that we do to the variable, is it do we need to go with a specific transformation ki we need to use a log or we need to square it? How do we decide on that?
Again, yeah. So again, that is a problem. See, suppose आपको पता चला heteroscedasticity है या कोई एक ऐसा problem या errors non-normally distributed है, and then you decide कि I need to transform my variables. Then again in this case, what you do is all the possible transformations that you find feasible, you run the model using that, and then you compare the models amongst them. And for that, you have two basic criteria through which you compare the models. And they are usually reported with these software. They are called archaic information criteria and Schwarz information criteria. So on the basis of जिसका lower value होगा, आप उसको select करते हो उस model को, and then you go ahead with that. So we generally run the model जो भी आपको best लगता है, and then you compare the models जिसका criteria के basis पे जो model select हो वो आपका best model होता है.
Sir, I have one doubt in this.
Yeah.
In the like the data set we tested the heteroscedasticity on that you gave that if you remember that X and Y data set that you had given based on I think consumption and
Okay. Yeah.
so that was the data set given by you. So you had tasted that there was heteroscedasticity, like we had interpreted based on that graph, like
Yeah.
of the explanatory variable and the residuals.
हाँ जी.
So I tried using Box-Cox transformation on that to remove heteroscedasticity.
Yeah.
So like after I used Box-Cox transformation, like according to NCV test, the heteroscedasticity was removed. Like it was coming to be according to NCV test, it was coming 0.159, which is greater than 0.5, like 0.05. But the thing is, the graph had still like in the graph there was still kind of pattern. So I don't know which to trust. Like NCV test, it was saying that heteroscedasticity has been removed and it's like 0.159 now, like according to NCV test. But the graph was still showing an evident pattern, so I couldn't understand.
Graph of what? There?
The graph of the explanatory and the residuals, like the graph that you told. And
Okay. All right. So first of all, जो हमने discuss किया था, just plotting the residuals against the explanatory variables, more or less, by the virtue of normal equations, if you are going by the linear model, they tend to be uncorrelated. So mostly, what should be done is either you plot the residual square on these explanatory variables.
Yes, sir. I also plotted that. Like there was this code plot model, 3123 जो graphs होते हैं ना plot for the fitted values versus residuals and for the squared. I don't remember exactly the exact reason why it is now. But all those graphs were showing pattern which should have been which should not show a pattern because the NCV test was saying there is no heteroscedasticity. I couldn't understand.
Okay, as far as so आपने ये R file में आपने ये code run किया है?
Yes, sir.
Okay, I'll check and I'll see what I need to or what needs to be done there. Don't worry.
Okay.
But mostly, basically,
I'll send it, sir.
Yeah, NCB test basically it's just a method, just one of the methods that we use to detect or test for heteroscedasticity. But okay, we'll see what can be done there.
I had just one question, that does Box-Cox transformation always works, that it actually always removes heteroscedasticity properly? Like,
See, box Cox transformation is just one of the method, where basically you transform an equation from a log linear to log linear and so on and so forth. So box Cox transformation is just a special case of a log transformation, and it basically makes a continuous data. So it need not work all the time. बट अगेन मतलब बहुत सारे इसमें बॉक्स कॉक्स का बहुत सारा लिमिटेशन है सो अनलेस तुम्हें लगता है कि यूज करना है करना चाहिए अदरवाइज मोस्टली यू शुड अवॉइड डूइंग बॉक्स कॉक्स ट्रांसफॉर्मेशंस
Sir,
okay.
या हाँ
so we found outliers in the data set. So
या
while deciding how many outliers to remove and when that like because the data set was of only 45 data points, and if we get 3-4 outliers and we remove that, definitely made the model a better fit. But how many to remove? Is there a basic criteria about that?
अगेन नो बेसिक क्राइटेरिया फॉर दैट सेतु आप क्या करते हो अगर आपको मान लीजिए कोई एक्सट्रीम ऑब्जर्वेशन है तो फर्स्ट ऑफ ऑल व्हाट वी डू इज वी रिमूव दैट ऑब्जर्वेशन फ्रॉम द डेटा सेट एंड देन वी अगेन रन द मॉडल. And if there are 2-3 observations which are extreme to all other observations, then again we try running two models where we include them and where we do not include them, and then we compare the models. So again, कोई basic criteria नहीं है. These are all various tests or various trials that we do. So basically क्या है जो model diagnostics है इट्स नॉट लाइक अ मैथमेटिकल रिलेशन या मैथमेटिकल फंक्शन टाइप नहीं कि अगर आपको एक टेस्ट दे दिया गया वो टेस्ट अगर आ गया तो the thing is done. No, it's like a statistical test. It's like if you just allow me or give me that leverage, it's like when a doctor tests a patient, he or she is not very sure about from the test. He always say 70%, 60%, 80%, 90%. Same way it works here as well. Apne model is what? Model is generally you are trying to generalize a relationship or you're trying to causally estimate the relation between two variables. Up when you go for the diagnostic check, there is no hard and fast rule. Like you try various methods. जो भी आपको बेस्ट रिजल्ट देता है आप उसके साथ प्रोसीड करते हो. अब इसी में कि आप बेस्ट रिजल्ट का मतलब क्या है तो दैट्स व्हाई यू आर द आप मॉडल रन कीजिए. Keep all the models. So one thing that for myself, what I do is whatever I do with the model or whatever I do with the variables, I keep all of them. So अगर कभी मुझे किसी मॉडल पे वापस भी जाना पड़ता है तो I can go back and I can compare the models. So best way is always comparing the models. पर कोई हार्ड एंड फास्ट क्राइटेरिया नहीं होगा कि हाँ आप इतने आउटलायर हटाओ इतने आउटलायर नहीं हटाओ. That again is just it depends on researcher to researcher. I'm really sorry I say this a lot, but this is the case. I don't know how to help it.
So sir, we go one by one, right? We
Correct.
start looking with one by one and compare all the models which we get on the way.
Correct, perfect.
So while comparing the models, which all parameters should be used?
Yeah, basically there are two criteria for which we use, which is based on the residual sum of squares and degrees of freedom. One is called archaic information criteria, and another is called Schwarz information criteria. So we'll discuss about this. But ये जो दो information criteria इसके basis पे model को compare करते हैं, and then we decide which model is the best model.
Okay, sir.
Yeah, Mohit.
सर लाइक मैंने और बहुत सारे लाइक मेरे फ्रेंड्स ने जो प्रॉब्लम फेस करा इस पर्टिकुलर प्रोजेक्ट में, like many of us talking about transformation and all, I also tried learning those things from, but I basically found the lack of some like organized thing कि जहाँ से हमने इस पर्टिकुलर चीज में पर्टिकुलर डेटा में डायग्नोस करते हैं. तो सर एक तो ये ऑर्गेनाइज थोड़ा सा लाइक कौन से टेस्ट लगाने हैं एंड ऑल कौन से डायग्नोस्टिक करने हैं, इस पे सर थोड़ा सा लाइट लाइक डिस्कस कर लीजिएगा. एंड सेकेंड थिंग सर, जैसे इस पर्टिकुलर डेटा मैंने नॉर्मेलिटी लाइक क्योंकि प्लॉट करा, तो जैसे रेजिडुअल थोड़ा लाइक इट्स नॉट एब्सोल्यूट नॉर्मल, लाइक लीनियर नहीं थे, तो
Yeah.
वो चीजें समझ में नहीं आ रही थी कहाँ पे कितना नॉर्मेलिटी टेस्ट होना चाहिए, नॉर्मल होना चाहिए. अगर नहीं है नॉर्मल तो देन व्हाट शुड वी डू, कंटिन्यू करें इसी मॉडल के साथ और कुछ ट्रांसफॉर्मेशन करना है? ये वाला इंफॉर्मेशन लैकिंग है सर हमारे में. एंड वन मोर थिंग, दैट व्हाट शुड बी द राइट अप्रोच फॉर द मॉडलिंग? इज इट लाइक पहले हमें नॉर्मेलिटी टेस्ट करना होगा, देन मॉडल करें, देन फिर हम डायग्नोस्टिक करें, या फिर लाइक डायरेक्ट हम मॉडल बनाए देन वी टेस्ट ऑल थिंग्स? सो सर थोड़ा ऑर्गेनाइज चीजें, लाइक मुझे फील हुआ कि सर हमें लैक है.
चलेगा
Please,
चलेगा
sir.
इस पे या आई रियली I really am grateful that you have pointed this out. पर दो चीज है यहाँ पे. फर्स्ट ऑफ ऑल कि जो मॉडल डायग्नोस्टिक्स की जितनी बातें हैं, दे आर ऑल रिलेटेड टू वेदर योर assumptions of the data set get violated or not. So whether it's non-normality or heteroscedasticity or multicollinearity or anything like that. So jitna bhi model diagnostic aap test karoge, they more or less are on these violations. So ये रही बात कि कितना कौन कौन से टेस्ट करने हैं, क्या ट्रांसफॉर्मेशन करना है, क्या ऑर्गेनाइजेशन चाहिए. इस पे आई कैन जस्ट से कि जो मॉडल डायग्नोस्टिक की बात है. सेकेंड बात कि द फर्स्ट स्टेप टुवर्ड्स बिल्डिंग अ मॉडल इज, ये तो क्वेश्चन मैंने आपको दिया इसलिए आपने इस पे टेस्ट किया. बट सपोज you are having your own research question and then you're trying to build a linear model. Oh, I'm really sorry, Rahul. Let me start this recording. And suppose you run a linear model, then so how do we exactly go about that? So the first and foremost step is your how many variables, what have you read about the literature pertaining to the research that you have talked about. तो उससे आपको बहुत सारी चीजें क्लियर हो जाती हैं. ये मेरा डिपेंडेंट वेरिएबल होगा, इतने इंडिपेंडेंट वेरिएबल्स को मुझे रखना है, उसके बीच में क्या फंक्शनल रिलेशन होगा. ये सब चीज आपका बहुत सारा लिटरेचर क्लियर कर देता है. एंड द लास्ट थिंग दैट आई से इज, जहां तक मॉडल डायग्नोस्टिक की बात है, तो सबसे पहला स्टेप जो करना चाहिए वो आपको रेसिडुअल्स को देखना चाहिए. क्योंकि जो आपका बेसिक अजम्पशन है कि रेसिडुअल मीन जीरो है, कांस्टेंट वेरिएंस है, इट नीड नॉट बी नॉर्मल. यू हैव टू अंडरस्टैंड दिस. नॉर्मैलिटी अजम्पशन हमें इन्फ्रेंस प्रोसीजर्स के लिए हेल्प करता है. So residuals अगर non-normal भी हैं, if you remember in our last discussion when we talked about possible problems with error terms or independent variables or parameters, so it is not that much of a problem if your error terms are not normally distributed, but it must have a mean zero, a constant variance. अगर वो सब नहीं आ रहा है तो वो एक possible आपको एक indication देता है that there is something wrong in the model. But nevertheless, I'll check all the assignment and I'll write my comments, जो भी जिसके assignment पे suit करेगा. And रही बात, as far as this question is concerned, I'll discuss this question in class and I'll also discuss model diagnostic at least one lecture अच्छे से. So that much.
Sir,
Yeah.
in our assignment, we didn't face any problem of heteroscedasticity or multicollinearity. But like, if you could teach us that if there is the problem of multicollinearity or heteroscedasticity, how to remove it properly and how to like test it.
Correct, Shalini. We'll do that.
Like how to remove that. Like.
One more thing, sir.
Thank you.
Yeah.
I don't know. It might be so silly, but जो residuals होता है वो chi-square distribution को follow करता है, जैसे मैंने book में पढ़ा था. So how we can apply those things in model? Like we need to check some chi-square distribution of that particular residuals or just like normal क्योंकि थोड़ा सा इस पे clarity चाहिए.
इसको we'll discuss. Can we discuss जब हम model diagnostic discuss कर रहे हो?
हाँ sir, please.
है ना?
Thank you sir.
Yeah.
Sir.
Yes, Manna.
Sir, isn't it a problem in this specific case that our dependent variable is a percentage? Because just like a linear probability model, our model can predict values above 100%.
Come again, थोड़ा आवाज कटा बीच में. Yeah.
So isn't it a problem that the dependent variable in this case is a percentage value? Because just like a linear probability model, our model
Yeah.
could predict values at over 100%.
Yes, sir. I agree with Manna on this one.
Yeah.
Like we have converted a binary into a numerical, and we are going ahead with a lot of things with a little too much ease. So we should be a little careful what we do before we do it.
Correct. But
So generally also, like, is it a problem if a dependent variable is a percentage value?
ideally, no, it should not be a problem. But as far as this particular assignment is concerned, let me just check whether linear probability model works better or not. But percentage में अगर आपका dependent variable है, that does not create a problem.
Oh, okay, fine.
Yeah.
Thanks.
क्योंकि as long as your variables can be quantified, and you see, even जब आप log लगाते हो, then also the changes or the coefficients give you in percentage terms. और यहाँ पे variables themselves expressed in percentage. So let me just check as far as this assignment is concerned whether LPM should be better than linear regression model. I do that.
So can we use can we use a logistic regression in this case, because a logistic regression usually assumes that you have a dependent variable of 0 or 1, right? So
Yeah.
like if it's an interval between 0 and 1 as a logistic regression, like can we apply it?
You see, logistic regression के बहुत सारे limitation है. In that case, your variable must be a binary. It must take on only two outputs, either yes, no, true, false, whatever it is. इस case में ये नहीं है. इस case में we are trying to, or इस case में the dependent variable is not a binary variable per se. That is, it does not give you just only two outcomes. समझ में आई बात ये?
Oh, yes, sir, got it.
लॉजिस्टिक रिग्रेशन के लिए आपका डिपेंडेंट वेरिएबल मस्ट गिव यू बाइनरी चॉइस. इन दिस केस इट इज नॉट इन दैट वे.
Yes, sir, so we can't use a logistic regression.
Correct. Yeah. Okay, anyone else? So shall we go ahead and discuss about heteroscedasticity, where we had just initiated our discussion?
Yes, sir.
All right. So basically what we had discussed so far was that possible violations or possible problems with whatever we have assumed as far as linear model is concerned, they are combinedly called as specification error. And one of the possible problems with the error term, that's what we had started discussing, is the problem of non-constant variance. That is the problem of heteroscedasticity. And so we'll discuss all these specification error precisely from three main points. First of all, how do we actually detect this problem? If the model suffers from the problem of heteroscedasticity or autocorrelation or multipolarity or functional form misspecification and so on and so forth. So there must be a proper way to detect this problem. After the detection, we must be able to answer, let's say our model suffers from heteroscedasticity, or our model suffers from any other functional form misspecification. So what might be the possible consequences on the properties of least squares? We all know that by the virtue of Gauss-Markov theorem, the OLS estimators, which are linear, but it also becomes the best estimator, meaning which it is efficient and consistent as far as estimator is concerned. So if these violations are observed, what are the consequences on the properties of the least square estimator? And what are the consequences on the estimated standard errors as well? क्योंकि estimated standard error मुझे क्यों चाहिए? when you talk about the variances of the OLS estimators, they use a formula sigma square, which we estimate using the residual sum of squares. So if there are certain problems with the residuals or the errors in the equation, then obviously the variances that we get or the estimated variances that we use need not be the correct variances, and that's how all the tests of significance which are based on these standard errors might be invalidated. And the last pillar is that after we have talked about detection and consequences of such problems, how do we exactly remove, or what are the possible ways through which we can remedy the problem? So just let me quickly recap. Let me just present 1 second. कि हमने क्या डिस्कस किया था, and then I move ahead. So we had talked about the various detection tests as far as heteroscedasticity is concerned. So we talked about the Anscombe. Sorry, can you all see the screen?
Yes, sir.
Yeah. So we talked about Anscombe and Ramsey reset test, which basically, before talking about the various detection method, one thing it should be absolutely clear is कि अगर residuals में problem है and we are trying to detect it, so and if you are trying to detect the problems, associated problems with the residuals via regression procedure, then jitni bhi test which have been suggested, as far as they are based on certain presumptions, all these tests use regression of the estimated residuals from the so usual method is आप पहले OLS run कर लो, जो आपका estimated जो residual आता है वो आप obtain कर लो, then either you regress this residuals on the polynomial functions or various interaction term of the explanatory variables, or if there are more than one independent variable, then you regress this residuals on the fitted values from the regression, or you square this residual and then you run the regression on various explanatory variables that you have, and इसी पे आपका more or less सारा detection test work करता है, as far as whether it is Anscombe reset test, or we discuss about the white heteroscedasticity test as well. We'll try and talk about these tests on R today. So Anscombe और reset test ये था कि आप जो estimated residuals आता है, आप regress these residuals. So एक और चीज before we proceed है, the reason why I discuss all this theory is that there are multiple software, multiple packages out there as far as these softwares are concerned, but कौन सा model और कौन सा package actually क्या करता है, that you should know, or that it should be completely understood by you. So that कहीं आपने देखा ब्रूश पगन टेस्ट किया हुआ है, कहीं आपने वाइट हेटेरोस्केडास्टिसिटी टेस्ट देखा, तो कौन से टेस्ट का क्या सिग्निफिकेंस या क्या इंटरप्रिटेशन, that at least you should know. That's why I am spending this much time. So you regress this estimated residuals on the explanatory variables. If you have one explanatory variable, then you simply square this explanatory variable and run the regression, or if you have more than one independent variable, then you simply take the fitted values of the regression and regress this estimated residuals on the squared value of the fitted values or the cube value of the fitted values, and so on and so forth. And then you test whether the coefficients attached with these fitted values from the regression are significant or not. Agar significant hai, it means there is the presence of heteroscedasticity. If they are not significant, it means there is no heteroscedasticity. White test similar logic पे based है. White test क्या बोलता है कि instead of running a regression of UI, what you do is you run the estimated residual का square on the fitted values, और जितने भी variables है वो variables पे उसके squared values पे और उसके एक interaction term पे. बट इन दोनों टेस्ट का लिमिटेशन है, एंस्कॉम और रीसेट टेस्ट का लिमिटेशन है कि आई रियली डोंट नो कि मुझे कितने फिटेड वैल्यूज के पास तो रुकना है जाके. whether I should stop at the fourth power of fitted values, or fifth power of fitted value, or second power of fitted value. I really don't know. And why टेस्ट का है कि अगर आपके पास दो वेरिएबल एक्सपेक्टेड वेरिएबल, तब तो ठीक है, आप उनके बीच में स्क्वायर्ड वैल्यूज उनका इंटरेक्शन टर्म करके आप रिग्रेशन रन कर दोगे. बट व्हेन यू हैव मोर नंबर ऑफ एक्सपेक्टेड वेरिएबल्स इन द मॉडल, एज मेनी पैरामीटर्स यू हैव, एंड इट क्रिएट्स अ प्रॉब्लम. सो दीज टेस्ट डू हैव लिमिटेशन. Then there is this very simple test called Gleiser test. Gleiser test क्या बोलता है कि so Gleiser test either tells you that you run a regression of UI hat, mod value of UI hat, on either xi or like this, or and then you test whether beta is equal to 0 or not, or out of such different models कौन सा model select करना, that would try to think in terms of the model information criteria. Now इस टाइप के जितने टेस्ट हैं which uses the regression procedure, they all are based on one fundamental implicit assumption behind them, is that you possibly know the variable which is influencing the variance of the error observation. That is, behind all these tests, the implicit assumption is that variance of UI, I know that it is sigma I square, but I also know that it is some multiplicative constant of an unknown influencing variable. And that's why you are either running this, regression of UI on various xi, xi square, or xi, x, various powers of fitted values, because ultimately what you're trying to say is that though the errors or the variance of these errors are not constant, but they are known to be a multiplicative constant of a known variable. But now whether this zi contains xi or xi square or e to the power x, it all depends on कि कौन सा टेस्ट किस फंक्शनल फॉर्म की बात कर रहा है. So जो भी हमने टेस्ट देखा, whether Gleiser test or White heteroscedasticity test or Ramsey test, they all are some functional transformation of this zi. But you must always remember that these tests assume that the variances of the error terms are known to be a multiplicative constant. और अगर ये actually true है, then one very immediate method to solve this problem of heteroscedasticity is कि जो भी आपका variable which you think is influencing, that is whichever variable is composed of this zi, you divide all the variables by that value, that influencing variable, and that becomes your weight. And then you simply run a OLS which is called as weighted least squares. But again, that is based on this assumption that the variances of the error terms is a known multiplicative constant. अगर ये assumption सही नहीं है तो weighted least square भी work नहीं करता. उस case में then you go for generalized least squares, which is what we'll discuss precisely in this lecture. Then you have some other test, and the test which basically we'll use in our today's session will be your Bruce-Pagan test. Now this is one such test which again starts with assumption that suppose if you're talking about heteroscedasticity, then variance of UI is equal to sigma I square. And now let us say there's some variable, let's say some variable or variables which you think influence this error variance. So let us say there are variables like Z1, Z2, say like a ZR, that influence this error variance. And if I can exactly form a function, that is sigma I square, can be related as then Bruce-Pagan test is mostly testing this joint hypothesis, null hypothesis, whether alpha 1, alpha 2, and so on and so forth equal to 0. और alternate hypothesis क्या होगा कि at least one of the coefficient which is multiplied or which is attached with this influencing variable is not zero. Now, Bruce-Pagan test is completely independent of what functional form you actually use. Whether you use x or whether you use x square or whether you use e to the power x or log of x, it does not depend on that. And will not go into what actually this test does, but more or less remember that Bruce-Pagan test is basically a variant of what is called a Lagrange multiplier test or LM test statistic, which is nothing but you simply run a regression like this, which you think influences the error variance. Then you calculate the regression sum of squares of this regression that you have run. And then you compute the statistic, which follows basically a chi-square distribution. I'm not going to that great detail. Agar iske baare mein thoda sa theory padhna hai, you can read whether Johnston or Woolrich in some theory diya hua hai. That is the statistic which is based on this Bruce-Pagan test follows a chi-square distribution, and you simply compare the
ये अल्फास क्या एक बार बताइए बिल्कुल.
Come again, dear. ये alphas.
Yeah.
These alphas are the coefficients which are attached with these explanatory variables or influencing variables which you think influences the error variance. You see, this is how I've written the function, that is sigma I square is some function of these zi's, where alpha 1, alpha 2, it tells you whether z1 or z2 or z3 or z4 and so on and so forth has some impact on the variance of the error term, because the dependent variable here in this case is error variances. Okay? Yeah. So we'll precisely use Bruce-Pagan test for detection of heteroscedasticity in today's class, and then we go about discussing the remedial. One of the remedial measure is your तो अगर ऐसा एक्चुअली है, अगर इससे मुझे पता चल जाता है और कि in सारे टेस्ट में basically your null hypothesis is that there is no heteroscedasticity, or there is no evidence of heteroscedasticity is your null hypothesis. So if your null hypothesis does not get rejected, it means your model does not suffer from heteroscedasticity. And if your null hypothesis gets rejected, it means your model suffers from heteroscedasticity. Once you detect that your model suffers from heteroscedasticity, the remedial measures is based on the same fundamental idea कि जो भी आपने regression run किया, and suppose this is x1 square and so on and so forth. This is the z1 that you're using, or let's say x1 is the variable which influences the sigma square. So what we generally do is we divide the entire OLS by x1 or under root xi or xi square, depending on what type of relation is there, what type of functional form relation between error variance and the regression is there, and we simply run the OLS, which is called a weighted least square. So weighted least square is based on this fundamental presumption that your error variances are known to be a multiplicative constant of one particular influencing variable. उसके बहुत सारे वेरिएंट है, will not go into all the variants. बहुत सारे केसेस में क्या होते हैं that instead of if you're more than one independent variable, so ये exactly पता कर पाना कि कौन सा variable actually influence कर रहा है मेरे error variance को, तो उसको overcome करने के लिए we simply take the fitted values of the regression and then we run this regression. That is, we run this estimated residual from the regression and on the fitted values, and then we check whether the coefficient is significant or not. If it is significant, then we divide the entire expression by the fitted values, and that's how we go for what is called as iterated weighted least square estimation, which is what we'll not discuss as far as our course is concerned, but these are certain variations which are there. Now, and then you have, some other tests like likelihood ratio test, which is again a very, very general test. So likelihood ratio test mein kya hai? If the number of observations are very large, so what we do is we first estimate the residuals by running the usual OLS, and then we divide the residuals into as many groups as we want. So let's say we divide the residuals into k groups, and we keep ni observation in the ith group, so that if you sum this ni, it comes out to be total number of observations. So हमने क्या किया? We usually ran the OLS through the usual estimation procedures. Then we divided the residuals exactly into k groups, such that the sum of observations across this k group is equal to the total number of observations. And then what we do is we estimate the error variances in the each group. So if you have the first group, let's say, so we estimate the error variances sigma I hat square for each group. So if I have k number of such groups, then I'll have k number of estimated error variances for each such groups. And then let the estimate of the error variance from the entire sample be denoted by sigma hat square. Again, this is a very general test. It does not assume anything about the functional form of or anything about the error variances, whether it is a known multiplicative constant or not. So if your number of observations are large, you run the usual OLS, you estimate the residuals, then you divide the residuals exactly into as many groups as you want. Now, kaise division hota? That's what we'll discuss in few minutes time. And then you compute the estimated error variance. Estimated error variance is what? Residual sum of squares divided by degrees of freedom. So residual sum of squares more or less आपका same ही है. Degrees of freedom हर एक groups का अलग अलग होगा. So, and then you compute the estimated error variance for the entire sample, which is your residual sum of squares upon n minus k, which is the number of degrees of freedom in this case. Then let us define a statistic called by lambda, which is nothing but the product of each such estimated error variances. So I goes from 1 to k, if I have k number of groups, product of each such estimated variances, sigma I hat to the power ni upon sigma hat to the power n. And this is a statistic. And if you take this statistic and multiply this, or take the logarithm, natural log of this statistic and multiply it by a multiplicative constant -2, then -2 ln lambda has a chi-square distribution, or it's a statistic which follows a chi-square distribution with degrees of freedom given by k minus 1. That is the number of groups minus 1. Now, how do we exactly divide the residuals? So, अगर आपके पास सिर्फ एक ही number of explanatory variables है, so mostly आप क्या करते हो? By the order of the absolute magnitude of the explanatory variables in the model, you order the residuals on the same basis. That is, if there's only one explanatory variables, the ordering of the residuals will be based on the absolute magnitude of that explanatory variable. In case of more than one explanatory variables, the predicted values of y should be used. That is the ascending or descending order in which manner you're distributing the errors into or residuals into various groups will depend on the values of the predicted or predicted values from the regression. Now, this is a general test. It does not assume anything about the various functions on which the error variances depend on these explanatory variables. In the last lecture, we had talked about Goldfeld and Korn test, which is a small sample test. Idea similar है, but small sample में तो उसमें क्या करते हैं? We simply again we run a separate regression for large values of x and small values of x. Then we compute the estimated error variances, that is RSS upon degrees of freedom. So let's say sigma 1 square hat, sigma 2 square hat, and then we check for the equality of variances. तो अगर आपका homoscedastic है error term, तो variances जो होगा उसको equal होगा. अगर heteroscedastic है error term, तो variances unequal होगा. So the reason I told you about all these tests, so that if you are asked in some interviews, or if you are asked whether how many type of tests are there, then you are able to answer. But as far as our coding is concerned, we'll mostly go about Bruce-Pagan test and White's heteroscedasticity test. And then the remedial measures based on this test will be your weighted least square estimation test.
So can you repeat the likelihood test once?
Likelihood ratio test,
Yeah, ये lambda वाला part.
या likelihood ratio test में देखो क्या है कि अगर मेरे पास large number of observation है, so what I do is I estimate the residuals. I estimate the residuals for the entire regression. Then I divide these residuals into, let's say, K groups or L groups or whatever groups that you wish to divide them. Then what we do is we estimate the error variances. Error variances is your sigma hat square, because ultimately sigma square का ये unbiased estimate होता है. तो we for each of such groups we estimate this error variances, and then we calculate the estimated error variance for the entire population or entire sample, that is undivided groups. And then we found out this statistic, which is again a formula. That is, if you take a product of this particular ratio, then you obtain lambda, and if you multiply this lambda by -2 ln, that is logarithm with base e, then this follows a chi-square distribution with k-1 degree of freedom. अब simply आप chi-square table पे जाइए, उसका values look कीजिए, compare the critical and calculated. अगर calculated ज़्यादा है critical से, you reject the null hypothesis. Again, the null hypothesis is that there is no heteroscedasticity or there is homoscedasticity, and so on and so forth. So, but likelihood ratio is basically used in large sample test. और जो Goldfeld quant test है, that basically is used in small sample test.
So how did you get this formula, like sigma I to the power ni and sigma to the power n? Why are we taking this? I didn't get this.
This is just a statistic there, as far as this is concerned. The derivation of the formula will be beyond our scope. So just for the time being, just understand that this is the statistic that we actually generate. ये हमें पता है, sigma I hat हमें पता है, sigma hat हमें पता है. And we take simply product of these estimated group error variances. We have not talked about derivation at all. So, but remember that this is a statistic that we get.
Okay, sir. Thank you.
Now, after having run the detection test, let us talk about the consequences of heteroscedasticity. Because consequences मुझे पता रहेंगे तभी I know that कि problem मेरा कितना serious है. So one of the consequences of heteroscedasticity is that your least square estimators, your LS estimators, they are still unbiased. That is, it does not. एक और चीज याद रखिएगा कि जो biasness unbiasedness है, it is a small sample property. And consistency and efficiency is a large sample property. So your OLS estimators are still unbiased. That is, expected value or average value of OLS estimator will still be equal to the true population parameter. But it is no longer the best estimator. That is, it loses the property of efficient estimator. So we say it is an inefficient estimator. So, जो best linear unbiased का, it loses B. It is no longer the best estimator. So अभी हमने देखा कि in presence of heteroscedasticity, either WS, that is weighted least square, have the minimum variance than OLS, or generalized least square estimators have the minimum variance than the OLS. And that's why OLS no longer remain the minimum variance unbiased estimator. That's why it loses the property of best. So the first consequence is that the least square estimators, they are still unbiased, but it is inefficient. And the second consequence is, guys, I'm not proving this in the notes that Neil would have shared with you. ये सारे proof हैं वहाँ पे. So I'd request you to go back and check the notes. I have shown there why it is unbiased, why it is inefficient. So we'll not take that in class. Instead, we'll focus on the R, coding as far as today's session is concerned. But अगर आपको derivation देखना है या आपको check करना है, you can go back and check the notes. It will be there as far as I recollect. और अगर नहीं होगा, then I'll share the derivation with you. So that will precisely be time based as far as derivation is concerned. Next part is that the estimates of the variances, the estimate of the variances are biased, and hence the usual test of significance is invalidated. Because the test of significance is based on the estimated variances, and estimated variances is based on the residual or the variances of the errors or residual term. And if the estimate itself is biased, that is sigma hat square itself is biased, then all the usual test of significance which is based on this biased estimator gets invalidated. But again, एक चीज याद रखिए कि अगर long run में, that is even if the LS estimators are biased in the small sample case, but in the long run it is efficient and consistent, you can still go ahead with this usual test of significance, provided you have a correct error variance, which is what we'll discuss in few moments time. So क्या अभी हमने देखा कि इन प्रेजेंस ऑफ हेट्रोस्केडास्टिसिटी क्या होता है, जो आपका वेरिएंस टर्म है एरर का, वो डिस्टर्ब हो जाता है. सो अगर आप एक्चुअली देखो, जो भी हम कॉन्सिक्वेंसेस की बात कर रहे हैं उसका अगर हम देखेंगे, तो इफ यू राइट वेरिएंस ऑफ योर ओएलएस एस्टिमेटर, वेरिएंस ऑफ बी, इट इज योर एक्सपेक्टेड वैल्यू, इफ यू रिमेंबर, बी माइनस बीटा का ट्रांसपोज. नाउ again, this was b minus beta is x transpose x inverse x transpose mu. So I'll simply write it here. Yeah. Now you see, जब हमारा एरर टर्म होमोस्केडास्टिक था, तो हमने क्या अज्यूम किया? सिंस ये स्टोकेस्टिक है, एक्सपेक्टेशन टर्म को हमने सिंपली इसके आगे लगा दिया, और ये टर्म क्या था मेरा सिग्मा स्क्वायर अगेन कांस्टेंट, सिग्मा स्क्वायर को हमने बाहर लिया, ये एक्स ट्रांसपोज एक्स इनवर्स एक्स ट्रांसपोज एक्स और ये एक्स ट्रांसपोज एक्स, ये आइडेंटिटी बन जाता था, एंड दैट्स व्हाई यू राइट सिग्मा स्क्वायर एक्स ट्रांसपोज एक्स इनवर्स. But now this is no longer the case because your errors are no longer homoscedastic. So your correct error variances can or should be written instead as, so now your expected mu transpose is no longer sigma square identity, but let us call it as sigma square some omega, where it is just a symbol which tells you that it is no longer a constant error variance. So instead of now taking this sigma square completely out, how do I write this as, this will still be stochastic, sorry, non-stochastic, this will still be non-stochastic. I'll take the expectation here, but instead of sigma square, now this is sigma square omega, so I can only take sigma square out. So I can write this as sigma square x transpose x inverse x transpose omega x transpose x inverse. So now this is the true variance of B in presence of heteroscedasticity. And if you simply, so if you notice in the assumption of homoscedasticity, this part is completely ignored. So if you run a usual test of significance on the basis of this heteroscedastic error variance, then the variance formula will only pick this part. And that's why the error variances or the estimation of this error variance will itself be biased, and the usual test of significance which are based on this will no longer be valid. Now, White, White, who has given his own test of detection of heteroscedasticity, he also gives his own method of solving this problem, which seems otherwise impossible, because you understand that एक तो आपके पास n number of observations है खाली, उससे आपको जो parameters तो करने ही करने आपको estimate. Apart from those parameters, if you have n number of observations, then you have extra n number of error variances also to estimate. So to estimate n plus k number of estimators out of n observations is an impossible task. So in a very influential article, White gave his own method of obtaining this estimated variance covariance matrix of OLS estimator, which in small sample is biased, but in large sample, they continue to be efficient and consistent. And that's why the standard errors of the OLS estimators, which are based on the White's suggested method, they are called as heteroscedasticity consistent standard error. And again, ये पूरा derivation is given in that notes. I'll just simply write that result over here. So White ने क्या बोला कि जो estimated variance of or variance covariance of OLS estimator है, that should be written as, so instead of looking at this problem like this, what he says is that this sigma square omega should be estimated by employing the residuals from the regression. So what he says is that sigma square omega hat should be understood as diagonal EI square. That is E1 square, E2 square, E3 square, so on till En square. Now these residuals are known to you. So now this sigma square omega hat is estimated using this. So now no longer I have to worry about this n number of extra estimators, because these residuals are obtained from the regression equation. And this, in his paper, he has shown that this variance of beta, this estimated variance of beta is an unbiased estimator in the larger sample case. In the small sample, it continues to be a biased estimator, but in the larger sample case, it is an efficient and consistent estimator, and hence, even under the presence of heteroscedasticity, if you're not worried about biasness, you can proceed along with the usual test of significance using what he calls as heteroscedastic consistent standard errors. So instead of using the usual standard errors, which are biased now, if you, so simply you can understand that this is one of the correction factor which he uses in order to estimate this whole matrix. And the estimated matrix is, instead of this whole term, this sigma square term, sigma square omega, it is simply written as diagonal EI square. And then this entire matrix is estimated, and it comes out to be a consistent and efficient estimator asymptotically, that is in larger sample case. So small sample may still your test of significance will be invalidated, but if you're generalizing it for the large sample case, using the White's heteroscedasticity consistent standard error, you can go ahead with the usual test of significance. All right, so this is what, as far as the theoretical aspects of heteroscedasticity is concerned. Uh, Now I request all of you to open R Studio, whichever form you're using, and we'll just try to run certain commands for test of heteroscedasticity. Then this, White's heteroscedastic consistent standard error command, and then we talk about W, that is weighted least square, as a remedial measures. So once again, a request, please open R Studio, all of you. Let me know once you are done. Okay, can you all see my screen?
Yes, sir.
And I again
Yes.
assume that, yeah, you all have opened your R Studio. Can I assume so?
Yes, sir.
All right. So before anything, what I'll request you to do is, you can all see my screen, right?
Yes, sir. Yes, it's visible.
Yes, sir. It's visible, sir.
So सबसे पहला चीज जो आपको करना है वो आपको ये पैकेज इंस्टॉल करना है, which is your LM test. So please do that. Please install these two packages and then also call them. That is by using library function. Is that done?
So doing it. It's installing.
ठीक है? Shall we go ahead?
Yes, sir.
All right. So after installing this, what I'll do is, first example we'll have for the command which gives us the White's heteroscedastic consistent standard error. So for this illustration purpose, I am using the data set GPA3 from package Woolrich. And by now, I'm sure that all of you understand how to load that data. So please do that for me. So what I'll do is data GPA3, the packages. Done? Guys, please respond.
Yes, sir.
Okay. Now, the next thing that I ask you to explore the data, which you must do, that is, just see how many variables are there, run a summary of the data and so on and so forth. And then my question is that you have to estimate a model where you run a regression, or that is linear model, linear regression. Dependent variable is your cumulative GPA, which is given as variable CUM GPA. And the independent variables that you have to use is given as SAT. You can see the description of all these variables. HSPERC, TOTHRS, female, black, white. But you have to run this regression only for spring data. That is, you have to run this regression only where the variable spring takes a value 1. Have you understood the question? You have to run a regression where the dependent variable is, side by side I'm running this, but it will be better if you run. So that let me see.
Sir, I'm also getting the same actually, this kind of thing.
Yeah. Hit GPA 3. So you see, these are certain variables which I have, which is your term. I guess it should be term 1, term 2, that is first term or second term. SAT will be SAT score, which I'm just assuming. Total hours, TOTHRS, cumulative GPA, season, first sem, CRS GPA, verbal math, TRM GPA, high school size, high school rank, ID, spring. Yeah, you see here is your spring. So you have to run a regression of taking cumulative GPA as the dependent variable, SAT score, total others, or sorry, total hours, female, black, white, and last is your HSPERC, but only for the spring data set. So how do I do this? That is, I only have to take out of the entire data a subset. So what I do is I store my regression up, kaise bhi karo, linear model. Cumulative GPA is my dependent variable, SAT score, total hours, HSPERC, female, black, white. Data that I have to take is GPA 3. And here the subset is, that is, मुझे कौन सा लेना है exactly. If you see subset का यहाँ पे आप देखोगे तो it explains कि what it actually does. So it returns subsets of vectors, matrices और data frames which meets condition. तो मुझे क्या चाहिए? मुझे चाहिए इस पूरे data frame का subset इस regression का run करना है जिसमें spring का value मुझे 1 चाहिए. तो spring equals 1. Yeah. Now, if you have already called this function, so you need not do this since I have not, so I'll call this.
So, could you please show the LM call once?
Yeah, yeah. ठीक है. I have ran a regression, cumulative GPA on SAT score, total hours, high school percentage, female, black, white, and all this from where the data set is GPA 3, but I only have to talk about the spring where it takes a value 1. So this is how I do that. So subset equals spring equals 1. That is, this subset gives you returns your vector or matrix which meets the condition. Here, this was the condition that I have to run this regression only for the spring data. So now there's this very nice command in the LM test package which gives you the various t-test of coefficients for all these intercepts, that is slope, intercepts, slope, and intercept coefficients, unka standard error and p-value. And the command is COEF test. What I do is COEF test, and the result is stored in REG. Yeah. So I hope all of you get this. Do you all get this?
Yes, sir.
Yeah. Now, I really don't know whether I have not checked for heteroscedasticity. I have not done any tests. So, I really don't know whether the t-value or the standard error that I get for all these coefficients are correct or not. So, but there's this very easy command on R, which simply gives you the White's heteroscedasticity consistent standard error. And that is that how do we write it is, again, we'll call this COEF test. COEF test. Again, my regression results are stored in REG. Then what I do is variance covariance matrix. So I simply write VCOV. कौन सा चाहिए मुझे? HCCM. That is heteroscedasticity consistent covariance matrix, basically iska ye hai. So for the same regression that I have run, I am obtaining a heteroscedastic consistent standard errors, and this is the command that we run, that is COEF test. From where? From the regression results, and the variance covariance matrix is now this HCCM. When you simply run this, you'll get this. Now, in this particular example, you do not see much of a difference, but if you actually accept and the sum of the slopes, you will notice that there are changes. There are changes in the standard error, there are changes in the t-value. However, in this particular example, there is no such drastic change as far as the p-value of such t-statistic is concerned. But if you're concerned about whether your model suffers from a heteroscedastic standard error or not, by running this command, what it does is this variance covariance matrix, the estimated जो भी हमने देखा था white का जो suggested model था, what it does is it removes the assumption of homoscedasticity from the model. That is, you no longer need to assume that your error terms are homoscedastic, because what we do is we try to estimate that sigma square omega hat, even if my errors are heteroscedastic, by the estimated residuals, and from that we get a large sample consistent and efficient standard error. So जो उसके बेसिस पे जो स्टैंडर्ड एरर आता है इस मैट्रिक्स को यूज करके, that gives us asymptotically, that is in large sample, valid t-test. So if you are just worried about the invalidation of the test of significance that we use, then we simply go for this SCCM command, and this is how we run it. So this is the example where we try and understand that what is the use of White's heteroscedastic consistent standard error. This is the one of the best practices is to run the heteroscedastic consistent standard error and just check whether anything changes from the usual t statistic or the correct estimated t statistic. If there is drastic change, accept the White's heteroscedastic consistent standard error and move ahead.
Sir,
Yeah,
so I didn't get why is the standard error and the t value changing here?
because ये जो मेरा है ये वाला t test of coefficients, this is based on the heteroscedastic जो estimated part है, that is it is based on non-assumption of homoscedasticity. That is, this command does not assume there is homoscedasticity. So जो आपका variance है, जो भी हमने देखा, जो correct variance will be sigma square x transpose x inverse. This will not be a correct variance if you have the presence of heteroscedasticity. पर अगर हम homoscedasticity assumption को मान ही नहीं रहे, तो जो मेरा correct variance है, that will include the extra term that White estimates using the estimated residuals, and that's why you see there is a difference of standard errors, because these standard errors of these OLS estimators have that formula sigma square. And that sigma square changes due to the estimated variance of OLS estimator that we use using the White's heteroscedasticity. समझ में आई ये बात?
Yes, sir, got it.
जो आपका जो वाइट कंसिस्टेंट हेट्रोस्केडास्टिक कंसिस्टेंट स्टैंडर्ड एरर था, उसका आप एस्टिमेटेड वेरिएंस देखो, इट इज डिफरेंट फ्रॉम द वेरिएंस ऑफ द एरर टर्म व्हेन इट इज अज्यूम्ड टू बी होमोस्केडास्टिक, है ना?
Yes, sir.
Yeah, and precisely that reason you see a different standard error as far as this is concerned. चलेगा?
Excuse me, sir.
Yeah.
Sir, after running a COEF test, my output is coming different.
क्या
Sir, in mine it's coming Z test instead of T test.
Sir, in mine it's actually showing only one value of x1.
I'm really sorry, but have you run the same regression? Just check once.
Yes, sir, because after running that head of GPA3, my output is coming same as yours, but COEF test is not.
Have you used this subset string is equal to 1?
Yes, sir.
Just check.
Yes, sir.
Regression is
sir, ये regression वाला we have to run this first and then COEF test, na?
correct, yeah.
Just a second, sir.
Sir,
Yeah.
sir, could you please repeat this t-test of coefficient again?
ये वाला?
Yes, sir. ये वाला and इसके बाद वाला एक और.
या ये टी टेस्ट ऑफ कोएफिशिएंट क्या है डियर, जो हम जनरली टी टेस्ट जो हाइपोथेसिस में पढ़े थे वही तो है ये सारा आपका इंटरसेप्ट है, इंटरसेप्ट टर्म एंड दीज आर द स्लोप कोएफिशिएंट्स, ये उसका वैल्यू, दिस इज द एसोसिएटेड स्टैंडर्ड एरर ऑफ दीज एस्टिमेटर्स. ये टी वैल्यू क्या है, ये स्टैंडर्ड एस्टिमेट डिवाइडेड बाय स्टैंडर्ड एरर विल बी योर टी वैल्यू, और ये एसोसिएटेड पी वैल्यू है. तो ये जो COEF टेस्ट है, ये जो कमांड है, दिस गिव्स यू टी टेस्ट ऑफ और द सिग्निफिकेंस फॉर ईच ऑफ दोस कोएफिशिएंट्स. पर ये जो कमांड है, दिस इज बेस्ड ऑन द अजम्पशन ऑफ अ होमोस्केडास्टिक एरर वेरिएंस, दैट इज यू अज्यूम योर एरर टर्म्स टू बी होमोस्केडास्टिक. बट इफ यू आर नॉट कंसर्न्ड अबाउट स्मॉल सैंपल, एक दैट इज अगर आपको चलता है कि स्मॉल सैंपल में बायस्ड भी है, इनएफिशिएंट भी है, बिकॉज दिस White's Heteroscedastic consistent standard error is for the larger sample, or when you have number of sample sizes sufficiently large. So if you're not concerned about your sample size in the short run, then what you instead do is, instead of running this usual COEF-TAST coefficient test command, what we do is the variance covariance matrix of the OLS estimator, in that we no longer assume homoscedasticity. So अगर आप homoscedasticity नहीं assume कर रहे हैं, तो जो estimated variance covariance matrix होगा OLS estimators का, that is different as compared to the case when your error terms are homoscedastic. And that is given by the term जो भी हमने just देखा था, x square, x omega hat x and so on so forth. वो जो extra term आता है, that is nothing but your estimated variance covariance matrix of your OLS estimator. वही आपको ये command HCCM देता है. Obviously, there are certain modifications to this as well. We are not going to that. So now, once you run this command, coef test reg is the variable on which the regression results are stored, and then the variance covariance matrix of the OLS estimator is this HCCM rather than the homoscedastic variance. तो उससे आपको ये आता है associated t-test of coefficients. Is this clear? जो changes आ रहे थे?
Yes, sir. Yes, sir. Thank you.
So what is this HCCM? VCOB is the variance covariance matrix, and HCCM is heteroscedastic.
Heteroscedastic consistent covariance matrix आप इसको कहो. ये command का नाम है dear. It is not based on actually जिसको हम समझते हैं. It just name. ठीक है? Shall I move ahead?
Sir, I have a request.
Yeah.
So could you just paste that regression wala syntax in the chat box, please, if possible?
Yeah.
Just that one.
हाँ, ये वाला चाहिए आपको?
Yes, sir. So the regression one.
वैसे I'll share this, Rahul, but ठीक है.
I'm just doing it side by side, but I'm still getting a different value as some of the other people. So I'm just checking what have I missed there. So.
अच्छा.
Sir. Like I'm not clear on this part, but I face this problem. आप जो ये कोड लिखते हो कंसोल में लिखते हो, तो जब ये फाइल शेयर करते हो, I don't think वो कंसोल में होता है, मतलब.
कौन सा फाइल शेयर करता हूँ? वो कंसोल नहीं. You see, when I share the file, what you have to do is you have to go and open script. जो आप जहाँ भी आप सेव करोगे, वो आप स्क्रिप्ट ओपन करोगे, it will come here. That is, it will come in your source portion. यहाँ पे आप उसको फिर रन करोगे. Is this clear? जो भी मैं फाइल करता हूँ, आप उसको सेव करोगे डेस्कटॉप में, and then you open R script or any R file. ठीक है? All right. So next example that we look at it, again, example from Woolridge only. And in this, we'll run a command for the Bruce-Pagan test for detection of heteroscedasticity. Again, the data set that I have used, and all these examples and exercises are given in the chapter 8 of Woolridge heteroscedasticity. So आपको कभी भी लगता है आपको go back and check कि कौन सा data set, कौन सा example लिया हमने. So the examples that I am taking is from the chapter heteroscedasticity. I think that is chapter 8 in my edition. I don't know which edition I'm using, but all these examples are there. So the next example that we are going to, or next command that we are going to run is for the BP test command. That is your Bruce-Pagan test. And for that, the data set that I'm using is H price 1. So again, I'll just load the data. ठीक है, जस्ट लेट मी सी द डेटा। ये काम हमेशा कीजिएगा। जो भी आपका पहला 2 क्वेश्चन था असाइनमेंट का भी, दैट वाज जस्ट टू मतलब गेट यू इन अ हैबिट कि व्हेनेवर यू कम अक्रॉस अ डेटा सेट यू मस्ट एक्सप्लोर द डेटा। तो ये मेरा पूरा डेटा सेट है एच प्राइस 1 का, वेयर आई हैव प्राइस ऑफ आई थिंक हाउस, I don't know what SS stands for. Bedrooms is number of bedrooms. Lot size should be plot size. I'm not too sure. Square feet, colonial. It's a binary variable, dummy variable. Then you have logarithm of price, logarithm of SS, and logarithm of lot size, logarithm of square feet. Okay. So this is the data set that I have. What I have to do is I have to run a regression of price on lot size, square feet, and bedrooms. So I'll simply do that. Again, let's say RG1, run a linear regression model of price on lot size, square feet, bedrooms. The data is your H price 1. So ये मेरा अगेन अब मैं COEF टेस्ट करूंगा तो मुझे जैसे अभी मैं किया था वो आ जाएगा। अब
So here also we are taking a subset, but why don't we mention it in that command?
Here we have taken a subset. No, I have not taken a subset there. वहां पे सबसेट था कि जो स्प्रिंग जहां पे वैल्यू 0 उसको हमने इग्नोर किया। वी ओनली टुक द वैल्यूज, दैट इज द वेक्टर ऑफ वैल्यूज करस्पॉन्डिंग टू स्प्रिंग इक्वल्स 1। हियर आई हैव जस्ट रन अ रिग्रेशन ऑफ प्राइस ऑन दीज वेरिएबल्स।
Okay, understood.
Yeah. All right. So again, देखो R में तो सिंपल कमांड है बीपी टेस्ट करके, बट बिफोर एंड we'll just do the manual way and the automatic way both. So क्या है तरीका हेटेरोस्केडासिटी डिटेक्ट करने का? अगेन गो बाय द लॉजिक, रेसिडुअल जो आएगा मेरे को वो मैं देखूंगा, देन स्क्वायर्ड वैल्यूज ऑफ दोज रेसिडुअल्स को आई विल रिग्रेस with the explanatory variables that I have used in the model. So let us go manually. So residual of regression function can be obtained by the function resid. So I'll just simply say resid rg1. So it will give me the residuals. Now what I have to do is I have to run. So let me say r2. I have to run a linear regression model of residual square. So resid reg1 square on what? On the explanatory variable that I have, the lot size, square feet, bedrooms, sorry, and the data that I have to use is H price. All right. Now what I do is I see the summary of this regression. All right. So now this is the regression result that I have got. And what I have done, I have regressed UI square on the explanatory variables that I have used. और आप डिफरेंट, अगर आपको वाइट हेटेरोस्केडासिटी टेस्ट करना है तो UI को आप xi स्क्वायर एंड इंटरेक्शन टर्म करके करोगे। उसका एक इजी कमांड है विच इज कॉल्ड फिटेड फंक्शन। ये तो था मैनुअल वे। An automatic way on R will be simply you call the library that is lm test function और उसमें एक कमांड होता है bp test, that stands for Bruch-Pagan test, and मुझे किसका करना है? regression results 1 का. I'll just do this. You'll see it will show you almost the same value. So BP test क्या है? मेरा Bruce-Paget test का null hypothesis है that there is no heteroscedasticity. Alternate hypothesis will be there is evidence of heteroscedasticity. So you see this is the result of Bruce-Paget test. And what you see is that the p-value is very, very low. It means, again, I told you that day that lower the p-value, greater the chance of rejection of null hypothesis. So in this case, you reject your null hypothesis. It means the data set and the regression model that you ran suffers from the problem of heteroscedasticity on the basis of Bruce-Paget test. Similarly, White test is also a variant of Bruce-Paget test only, where in the auxiliary regression we do not run the regression of squared residuals on the original regressors, but हम क्या करते हैं? Apart from the original regressors, we also add interactions and polynomials of those regression, or अगर आप ANSCOM या reset test कर रहे हो, तो इस रेसिडुअल्स को आप रिग्रेस करोगे फिटेड वैल्यूज ऑफ y हैट दैट इज y पे और उनके पॉलिनोमियल्स पे. अब ये भी बहुत इजी कर सकते हैं इसको सिंपली अगेन लेट अस मूव दिस एंड उसका भी सेम कमांड है. सो व्हाट वी डू इज बीपी टेस्ट.
Excuse me, sir.
Yeah.
Sir, can you just scroll up for a second? Just I want to see the R2 wala command. That's it, sir.
जैसे आप रिग्रेशन लिखते हो, मैंने सिंपली उसी को रिग्रेशन यहाँ पे मॉडल में लिखा है, नथिंग एल्स.
ओके सर, थैंक यू.
सर थोड़ा एक बार ऊपर स्क्रॉल कीजिए.
हाँ सर, एक सेकंड सर, लिख लेते साथ साथ में कर लेंगे सर.
ये वाला?
हाँ सर, R2 के
इसके ऊपर वाला भी सर एक बार.
हाँ ठीक है. डेटा सेट इज H प्राइस 1. ये रिग्रेशन है. रेसिडुअल्स निकालने के लिए या तो आप सिंपली y माइनस y हैड करोगे या रेसिड फंक्शन है उससे आप रेसिडुअल्स निकल जाएगा आपको. नेक्स्ट मैंने क्या किया है, एक नया वेरिएबल स्टोर किया R2 के नाम से, वेयर आई हैव रन द रिग्रेशन ऑफ रेसिडुअल ऑब्टेन्ड फ्रॉम द यूजुअल OLS उसका स्क्वायर्ड अगेंस्ट द एक्सप्लेनेटरी वेरिएबल्स दैट आई हैव इन द मॉडल. इससे भी मुझे
So how are we reading the from the R2 function? How are we seeing the heteroscedasticity presence here?
ये डियर ये क्या है आपका रेसिड REG1 दैट इज रिग्रेशन रिजल्ट जो आया उसका रेसिडुअल का स्क्वायर. इट इज बीइंग रिग्रेस्ड ऑन द एक्सप्लेनेटरी वेरिएबल्स इन द मॉडल, राइट?
Yes sir.
ये आपका फॉर्मूला. तो आपने जो ये समरी दैट इज योर रिग्रेशन रिजल्ट रन किया, उसका नल हाइपोथेसिस क्या है आपका? दैट देयर इज नो हेटेरोस्केडास्टिसिटी, राइट?
Yes sir.
Alternate hypothesis is what? There is evidence of heteroscedasticity. So यहाँ पे देखो F statistic क्या है आपका जो joint hypothesis है? F statistic is 5.339 and which is a p-value of 0.002, almost very, very low percentage, right? Probability.
Yes sir.
To lower the p-value, greater is the chance of rejection of null hypothesis. Correct?
Yes sir.
It means
There is
evidence of heteroscedasticity.
Got it.
चलेगा?
Yes sir.
All right. So I'll just run the white test for today.
Sir,
yeah.
One more thing. ये सब BP टेस्ट का जो नंबर आया 14.092, इसका क्या सिग्निफिकेंस है सर? यहाँ पे उसको कैसे हम कुछ इंटरप्रेट करते हैं?
डियर बीपी ये जो आया ये आपका काई स्क्वायर वैल्यू है. यू रिमेंबर मैंने क्या बोला था कि जो बीपी टेस्ट का जो स्टैटिस्टिक होता है वो काई स्क्वायर फॉलो करता है, राइट? अभी जो बीपी टेस्ट पढ़ रहे थे देर, तो जो हमने बोला था कि बीपी टेस्ट का जो थ्योरी डिस्कस कर रहे थे उसमें जो स्टैटिस्टिक आता है, ये जो बीपी है वो स्टैटिस्टिक वैल्यू है डियर. वो वैल्यू है 14.092 and this value follows a chi-square distribution with degrees of freedom given by k-1, मतलब where k is the number of variables in the regression that you run excluding including the constant. So यहाँ पे मेरे पास 4 वेरिएबल था, 4 - 1 3, उसका p वैल्यू है ये bp का, दैट इज वो स्टैटिस्टिक का प्रोबेबिलिटी वैल्यू है बहुत कम 0.00272. चलेगा?
हाँ सर.
Okay, all right. So let us now just take one more step ahead and run a white test for this. So again, the command follows the same. White test में क्या करते हैं हम dear? White test में या तो we simply take the fitted values, उसकी पॉलिनोमियल पे हम रन करते हैं. I'm really sorry, I'm getting some junk calls. Yeah. So the command that we use for white can you all hear me?
Yes, I can.
Yeah.
Yes, sir.
The command that we use for white test is we simply say bp test again. Then what I do is I take the variable stored at reg1. Then I separate it by tilde, then fitted values of reg. Plus नाउ जब भी आपको जैसे अभी तक हम जो भी फॉर्मूला देख रहे थे वो सिंपली एक लीनियर एडिशन था, दैट इज y इक्वल टू बीटा नॉट प्लस बीटा 1 x प्लस बीटा 2 एंड सो ऑन सो फोर्थ. जैसे आपको पॉलिनोमियल टर्म्स आ जाता है, व्हाट यू डू इज यू सिंपली टेक दिस, you write an I in front of that. So I fitted again, fitted value of regression 1, उसका पॉलिनोमियल लेना है मुझे. So now this is the white test for the same, and this is the white test that we do. So इसमें हमने क्या किया है, जो हमने रिग्रेशन रन किया reg1 वेरिएबल, जो ओरिजिनल रिग्रेशन है ये, उस ओरिजिनल रिग्रेशन को हमने लिया है, दैट्स व्हाट दिस फॉर्मूला सेज, दैट इज बीपी टेस्ट ऑन व्हाट reg1. क्या किया है हमने, फिटेड वैल्यू और फिटेड वैल्यू के स्क्वायर को अगर आप थर्ड पावर करना चाहते थे, अगेन प्लस आई फिटेड वैल्यू ऑफ reg1 टू द पावर 3, ऐसे करके आप जा सकते हैं.
So what is I here?
I is generally used as a syntax there when you have polynomials attached in the regression model. जैसे आपका y is equal to beta naught plus beta 1 x1 square beta 2 x2 square and so on so forth रहेगा. तो अभी तक जो हम सिंपली प्लस यूज करते थे, दैट इज सिंपली अ लीनियर एडिशन. बट अगर आपके पास अगर पॉलिनोमियल आता है, यू सिंपली टेक I is a syntax mainly, and you attach it, with the variables, explanative variables on which the polynomials are there. Is this clear?
Yes, sir.
All right.
So is this taking the cross products into consideration also?
It is not taking the cross product, Manna. It has taken the fitted values from the regression. You can run the same regression as well, where instead of fitted values, what you'll do is you'll take the residuals from the reg1 and you regress that residue. You can have the manual command here as well, where what I'll do is I'll take the residuals of reg1 variable and I regress it against the explanative variables that I. यहाँ पे मेरे पास देखो 3 number of explanative variables है. So in order to talk about the cross product and the square term, so how many number of variables I'll have to use? It will be k into k plus 1 divided by 2. So 3 into 4 divided by 2. One second. I think there's some mistake that I'm making. It should be k into in number of मेरे पास variable है. Yeah, 6. Correct. So instead of writing all those variables, what we have done here is we have simply taken the फिटेड वैल्यूज फ्रॉम द रिग्रेशन. आइडियली आप वो भी कर सकते हो, देयर इज नो harm in that. बट उसके लिए यू कैन रन द मैनुअल कमांड, जैसे आप रिग्रेशन नॉर्मली रिजल्ट्स लिखते हो वैसे, बट दिस डज नॉट टेक द इंटरेक्शन टर्म एज इट इज.
Okay, sir.
ठीक है ना? या all right, are you there with me till here?
Sir, next time could you explain this I thing again? I didn't really catch onto it.
Yeah, Neil, this I is a form of syntax जो कि हम लिखते हैं जब मान लो पॉलिनोमियल्स होता है. पॉलिनोमियल्स मींस जब आप, जैसे अभी तक जो सिंटैक्स है ये देखो, when you write a regression like this, how your function looks like. Your function looks like ui square is equal to beta naught plus beta 1 times lot size plus beta 2 times square feet plus beta 3 times bedrooms, right?
Yes, sir.
है ना? अब यहीं पे मान लो आपका लॉट साइज स्क्वायर पे आप रिग्रेस कर रहे हो उसको, ठीक है?
All right.
So in order to write square terms or polynomial terms in the regression formula, what we do is we write this syntax I before the coefficient, before the variable on which polynomials are there.
Sir, also, sir, अगर LM में तो I would understand, but I am not very clear with BP test का मतलब अगर हम लोग if we extend the bracket, तो I'm not very sure about all of that. So that is also coming into factor.
Which bracket, dear?
So like when we've done BP test, I will only do BP test and I'll write the model's name usually. But
Correct.
here when we're extending it, then I'm getting confused ki what are the extra terms trying to explain now?
This is that this is that variant of, you can say, Ramsey reset test or Anscombe test और white का ही variant, जहां पे हमने क्या किया है, जो रिग्रेशन रिजल्ट्स का जो फिटेड वैल्यूज है और उसका जो सेकेंड पावर ऑफ फिटेड वैल्यूज है उसको मैंने रिग्रेस किया है विद द रेसिडुअल्स ऑफ द रिग्रेशन इक्वेशन. सो ये वाइट टेस्ट का या जनरल कमांड है आर पे. दिस इज हाउ वी राइट इट हियर. इफ यू वांट टू डू इट मैनुअली, व्हाट यू can do here is you simply calculate the residuals from the regression, that is resid reg1, that will give you the residuals. Now you run a regression of residuals on just a simple LM model, residuals on fitted reg1 plus I fitted reg1 to the power 2. That will also give you the same result. और अगर आप एक्सप्लेनेटरी वेरिएबल दैट इज x के टर्म में लिखना चाहते हो, सो यू टेक द रेसिडुअल्स और रेसिडुअल स्क्वायर्स, यू रिग्रेस इट अपॉन द बेडरूम स्क्वायर फीट एंड द अदर वेरिएबल इज lot size, then square of these and then interaction term of this. So in that case the number of parameters to estimate will increase by lot.
So are we telling the machine to do a linear check with linear check with all the parameters with all the variables and then check a square with all the variables?
Correct.
Okay.
Yeah. So जो if you remember the test of significance that test of detection test of heteroscedasticity that we have discussed, these are the tests which if you are trying to detect heteroscedasticity through regression, what we do is we generally regress either ui or ui square with the explanatory variables. So instead of running a manual command, this is the automatic command of white test on R, जो कि फिटेड वैल्यूज के साथ रन होता है. अगर आप मैनुअली इसको रन करना चाहते हो तो सिंपली फॉलो द फॉर्मूला और फॉलो द स्टेप दैट द वे वी राइट वाइट्स टेस्ट ऑन पेपर. सेम थिंग आपको यहां पे एज अ कोड लिखना है. चलेगा?
Yes, sir.
So
Okay, yeah.
So one more question
Haji.
unrelated to this. Sir, like we solved a question using the matrix method.
Yeah.
So I just wanted to know, how do we extract a particular value from a matrix?
uh, that is again very simple, Ayushi. पहले तो आपको बुक पढ़ना चाहिए जो मैंने बुक भेजा है. Second thing, if you want to source any one particular, row or column from, matrix, what we do is, अगर मुझे suppose row निकालना है, let's say row 2 निकालना है matrix से, तो what I'll do is 2 comma I'll leave it blank. So what it will do is, it will just give me the second row या second column निकालना है, matrix का नाम लिखूंगा, bigger bracket, row को blank छोड़ूंगा, comma 2. So it will give me the second column of the matrix. इसी तरह मतलब आपको सेकंड से सेवेंथ कॉलम चाहिए, सो बिगर ब्रैकेट, जो मैट्रिक्स जिस पे स्टोर्ड है वेरिएबल का नाम, उसके बाद बिगर ब्रैकेट कॉमा, बिकॉज आई डोंट वांट एनी रो, नाउ 2 सेमीकोलन 7 सेमीकोलन 3 सेमीकोलन 4, जितना भी आपको चाहिए. अगर आपको बीच बीच से चाहिए, जैसे सेकंड कॉलम चाहिए, सेवेंथ कॉलम चाहिए, 10th कॉलम चाहिए, सो अगेन आई डू द सेम थिंग, राइट द वेरिएबल नेम, बिगर ब्रैकेट कॉमा, then I'll have the vector. That is, vector will be used by the concatenate, that is C. So C, second column, comma 4, comma 8. So it will give me second column, fourth column, and 8th column from the matrix. उसी तरह किसी भी vector से. So basically, this is a way to extract a subset of the vector, nothing else.
Okay, got it. And sir, lag variables कैसे लेते हैं?
Lag variables लेते कैसे मतलब?
How do we include the lag variables in our regression model?
You simply write the variable name -1 there with a subscript. I'll deal with this. जब इसको polynomial के अलावा we'll write log and lag, so we'll talk about this, don't worry.
Okay sir.
But syntax same ही रहता है, कुछ ज़्यादा difference नहीं है. All right, is this clear?
Yes sir.
So what I'll do is I'll stop here. I'll send you the syntax of weighted least square and generalized least squares as well, again by quoting the example from Woolrich only. Just run that command yourself. Agar koi problem hota hai, then we'll take that up in tomorrow's lecture. Otherwise, we'll move ahead and we'll start discussing the other functional form misspecifications. Is that fine with all of you?
Sir, could you explain generalized least square in the next class, please?
Correct, I'll do that. I'll do that, no issue. But run that command on R so that we don't spend time again. Agar koi problem hota, then I'll definitely take it up on R. Agar nahi hota, you're able to run that, then I'll move ahead. ठीक है?
Sir.
हाँ जी.
Could you suggest some studies जहाँ पे regression diagnostics अच्छे से किया गया हो? Because from the book R for Everyone, उसमें we had these 4 plots which typically are from the like plot R model. Then we get those 4 plots, and one more regression diagnostic था about histogram of the residuals. So these 5, but the interpretations were not clear enough, sir. So like
भूषण, इंटरप्रिटेशन के लिए हमेशा कोई भी, जैसे वोल्रिच एक अच्छा टेक्स्ट बुक है इंटरप्रेट करने के लिए कोएफिशिएंट्स को. रही बात की आर में मतलब आर तो एक सॉफ्टवेयर है जो कि सिंपली तुम्हें रिजल्ट देता है डेयर इंस्टेड ऑफ पेन एंड पेपर. इंटरप्रिटेशन के लिए वन थिंग यू ऑलवेज कीप इन माइंड की, सॉरी 2 चीज आपको याद रखना चाहिए इंटरप्रेट करने के लिए जहां भी ओएलएस का बात आता है. पहला चीज तो यूनिट ऑफ मेजरमेंट क्या है, whether it is in units or it is in percentage points or it is in $1,000, whatever it is, एक तो वो याद रखना है. सेकेंड थिंग आपको देखना है कि कि कौन सा साइड स्केल्ड अप है. अगर मान लो कोई सपोज एक्सप्लेनेटरी वेरिएबल्स थाउजेंड्स में है, आपका डिपेंडेंट वेरिएबल हंड्रेड्स में है, तो कैसे भी इंटरप्रेट करना है. लॉग में, एक लॉग में नहीं है. इंटरप्रिटेशन का मतलब हमेशा सेम रहेगा कि अगर जो भी आपका रिग्रेशन कोएफिशिएंट आ रहा है वो आपको सिंपली पार्शियल वैल्यू दे रहा है. partial impact of that explanative variable on the dependent variable. Just keep this fact in mind, and more often than not, you will not face problem as far as interpreting the regression equations are concerned. और रही बात अच्छे मतलब वुलरिज आप पढ़ सकते हो, देन जीएस मडाला इज अ वेरी गुड टेक्स्ट बुक, वो भी आप पढ़ सकते हो. इन सब में इंटरप्रिटेशन अच्छे से दिया रहता है, बट वुलरिज विल सफाइस आई गेस.
So,
Yes, sir.
हाँ जी.
so for the interpretation of the graphs of regression diagnostics कि हाँ read कैसे करना है, can you provide us a reference for that?
मॉडल डायग्नोस्टिक विल डिस्कस अबाउट दैट आयुषी. वो कैसे, किस ग्राफ को हम कैसे एक्सप्लेन करेंगे, क्या उससे हम इन्फर करते हैं, विल डिस्कस ऑल दिस. जो असाइनमेंट हमने आई डिस्कस दैट असाइनमेंट इन द क्लास, डोंट वरी.
Sir, can you suggest some measure other than Box-Cox transformation to remove heteroscedasticity?
देखो बॉक्स कॉस एक जनरल फंक्शन है डियर, विच इज, जैसे मोस्टली लोग क्या करते हैं, लॉगरिथमिक ट्रांसफॉर्मेशन करते हैं. बॉक्स कॉक्स इज अ ट्रांसफॉर्मेशन विच more or less summarizes for, or which you can say, if you actually see how Box-Cox transformation is done, it is based on a single parameter, whether it's lambda, beta, whatever you say. So जहां पे भी basically it's a power transformation. तो अगर आपका पावर 0 है तो वो लॉगरिथमिक ट्रांसफॉर्मेशन हो जाता है. पावर 0 नहीं होता है, then it comes in a ratio form. So it's a general transformation there. Logarithmic transformation is just one part of Box-Cox transformation. So और again Box-Cox transformation again एक approximation है एक नॉन लीनियर को लीनियर बनाने का.
Yes, actually, I was wanting to use some other method to remove heteroscedasticity. So that's why I was asking you if there is some other thing that you can recommend.
See, देखो अक्सर ट्रांसफॉर्मेशन से काम हो जाता है हेटेरोस्केडासिटी रिमूव करने के लिए, बट then again there are cases where you are not able to remove the presence of heteroscedastic error variances. So in that case, अगर ट्रांसफॉर्मेशन काम नहीं कर रहा, बिकॉज ट्रांसफॉर्मेशन नीड नॉट वर्क ऑल द टाइम, सो इन दैट केस वी गो फॉर दिस GLS and there are maximum likelihood estimators as well. So but for our purpose, I think Box-Cox transformation, if you understand how it works, that is more than enough. So take various different values of lambda and see if that transformation works in removing heteroscedasticity or not. If it does, then good. If it doesn't, then go for some other methods, like go for generalized least squares or weighted least square. उससे भी हो सकता है.
Okay, so actually I will send you a file where it's not working. If you just once look through it.
चलेगा.
Okay, sir.
So,
हाँ जी.
so just a request, sir, can we have a class, like even a 1-hour class, just to discuss the various data types and how do we deal with them?
Various data types is in cross section, time series, pooled, इस type का.
Yes, sir.
चलेगा.
Thank you so much, sir.
No issue. All right then. So I'll wind up my lecture. I'll send you the syntax. Go through that. And I'll discuss the theoretical portion of general least square and weighted least square in tomorrow's lecture. And we'll start with the functional form specification test. Mainly reset test we'll discuss. And then we proceed ahead and talk about multicollinearity in brief. And then I wish to start time series as soon as possible. That's what. And when is your last date for this semester? July, right?
Yes, sir. First week of July. We have exams.
First week of July.
Matlab it would be, yeah, sir. We have exams from 12th, so it will be like most probably till last of June.
Have your exams not been postponed, considering first tutorial there was some break in the between?
No, sir, it was notified that it won't be postponed the end semester.
All right, so I'll request 29 June. So it will just be a huge cooperation from your side as well. What we'll do is from now on, जो theory portion रहेगा, what I'll do is either if the notes given to you by Neil, if it covers that theory, then I'll try to skip, and mostly we'll try to run these commands on R. So that I want to discuss time series with you अच्छे से, so that once you go in the advanced econometrics, then थोड़ा और भी अच्छे से चीजें clear हो. चलेगा. Just a bit of cooperation. So because the time is very near now.